Hello children, so this is the first topic in this video. It is AC circuit containing resistor only. So this is the way we will be drawing. This is an AC circuit and it is containing a resistor of resistance R only. So as we know, the general expression for alternating EMF is we have already done this, E is equal to E naught sin omega t. If you wish, you can note down it with the symbol V also. EMF is voltage. So if you wish, you can write like this. Okay? Or you can use E. Okay. So what is the opposition of resistor? Opposition of resistor. So we all know that opposition has a special name which is called resistance. Right. So now if we have voltage, that is EMF, and opposition, we can find out current is voltage upon opposition. So it's I is equal to E naught sin omega t upon R. Okay, so I is equal to this E naught by R. Let it be I naught, that is maximum current. So I naught sin omega t. So this is your equation number 2. And what you began with is equation number 1. So I'm writing that equation again. I is alternating current and this is alternating EMF. E is equal to E naught sin omega t. So what do you see from here? That both are a function of sine. So it means both are in same phase. It means in an AC circuit containing resistor only, voltage and current, or you can write E and I, are in same phase because they both are a function of sine omega t. They are in same phase, or you can say phase difference is 0. So then we have to draw this phasor diagram. So you can see this one, this is phasor diagram. So here you can see this is your I naught, this line is your I naught, this is V naught, E naught. Okay, so let me draw it for you. Yes, let us see. Phasor diagram we are drawing for AC circuit containing resistor only. So this is your voltage. E is equal to E naught sin omega t. So this blue line is representing E naught and this is omega t. So here will be E naught cos omega t along theta s. So here is your this E. So this is for E. Now current is also in same phase. Okay, so current is voltage upon resistance, so current will be little less. So this is current, this is I naught. It is in same phase, so I is equal to I naught sin omega t. So this is your I. Why? Because base component will be cos omega t wala factor. So this is your sin omega t wala factor. The both are in same phase. This is called phasor diagram. Okay, now we have to do a graphical presentation also. So this is the graphical presentation. You can see it is simple. Both are a function of sine. So sine curve they will draw. Upper one will be voltage, V is equal to V naught sin omega t or E is equal to E naught sin omega t. And lower wala is for current. So you can see there is no time difference, there is no phase difference. Both are achieving 0 together. Peak values together. This is I naught. Peak value of voltage is V naught. You will label it as this. Both are achieving 0 again, both are achieving negative peak also together. So this is your minus V naught, and the smaller one is minus I naught. So this is how you have to show. Getting to the next topic now. Yeah, so next topic is AC circuit containing inductor only. AC circuit containing inductor only. So we'll draw. This is your AC source, and it is containing only inductor. The solenoidal coil is an inductor. So what is the general equation for alternating EMF that is applied here? You have applied alternating AC here, alternating current here, EMF here. So it is E is equal to E naught sin omega t, right? This is what you have applied. So E applied, alternating EMF applied is given by E naught sin omega t. And you know already that if it is an inductor, so self-inductance, self-induced EMF will be developed here. Induced EMF will be developed. So what is that induced EMF is equal to? If you remember, it is minus d phi by dt. And your phi is proportional to I. This is how we do it. Removing proportionality, we get Li. So we have already done it. So we'll write induced EMF will be equal to minus d by dt. Let us substitute the value of phi. It's Li. So induced EMF induced is equal to minus L di by dt. So there are two EMFs. One you have applied, one which is developed across the inductor. So this is E induced, which is equal to minus L di by dt. Now you can see that there are two voltages, 1 and 1, two voltages are there. So we'll use Kirchhoff's voltage law. Using Kirchhoff's voltage law, Kirchhoff's second law, Kirchhoff's voltage law, loop law. So what is that equal to? Sum of voltages is equal to 0. In the circuit, I'm talking about that circuit, in this circuit. This voltage plus this voltage is equal to 0. So what is one voltage? This is E applied. And what is the second voltage? That is E induced. What is E applied equal to? It's E naught sin omega t. And E induced is equal to minus L di by dt. So we'll take this quantity that side. So this will be written as E naught sin omega t is equal to L di by dt. Okay, now we will take dt this side. So E naught L also we are bringing this side, sin omega t dt. And this side is di. Now we'll integrate both the sides. Di will change into I. And this is equal to E naught by L outside. Sin's integration will be minus cos. So minus here, cos here. And what is written with t is omega, that will come down. This is how integration is done. So we have an equation. I is equal to minus E naught by omega L cos omega t. We will always remember this equation. This is the original equation, third equation. Okay, current expression is ready. But then I will take this as this quantity as peak current. So my peak current is equal to E naught by omega L. So I'm writing it as I is equal to I naught, minus and cos omega t. This equation also I will remember. This is current's equation. Okay. So now see, voltage applied was E naught sin omega t. And current in the circuit is this. So one is cos function, one is sine function. So we can convert it into sine. We can comment something about the relationship. So now sine 90 plus omega t is equal to cos omega t, and sine 90 minus omega t is also cos omega t. So we have to convert cos omega t, this cos omega t. So we can write either this or this. But here is negative sign. So if negative sign will be taken inside, it will go here, it will go here. Omega t cannot be negative, so we cannot go by this. We'll be substituting this as cos omega t. Again listen, cos omega t can be substituted as this. If we substitute this here, then this negative sign which is here will go inside, will make this also negative and this also negative. Omega t cannot be taken negative, so I'm using this. So that when negative will go inside, this will be negative, this will be positive. Omega t has to be positive. So we'll substitute I is equal to minus I naught. In place of cos omega t, I'm putting this. That is sine 90 minus omega t. Now I'll take minus inside. So I is equal to I naught sine. This will be negative, this will be positive. So omega t minus 90. This is my final expression for current that I know. Okay, and EMF is this. So we have to comment about the relationship, current voltage relationship, like we did in case of AC circuit containing resistor only. Now this is the case of AC circuit containing inductor only. So what will we write? That from 5 and 1 we can see that this is omega t and this is omega t minus 90. So current is lagging behind the voltage by a phase angle of 90. So we'll write in an AC circuit containing inductor only, current lags behind voltage by a phase angle of pi by 2 radian or 90 degree. Okay, and we can talk in terms of time also. Then how much time is it lagging by? So you know, for 360 degree time is time period. So for 90 degree, because phase difference is 90 degree, time difference is 3 by 4. So you can say voltage, or you can say EMF will achieve, because it is ahead, no? Current is lagging, voltage is ahead. So voltage will achieve zero, and then peak, then zero, then minus peak, okay, then zero, before current, okay, by a time difference of t by 4. Okay, so this is the relationship. We have a relationship in an AC circuit containing inductor only. You'll have to memorize the relationship. It's E naught sine omega t, and current is I naught sine omega t minus 90. Okay, then we have to go for phasor diagram. So I have included phasor diagram here. You can see this as phasor diagram. This is phasor diagram. This is graphical presentation. So let us try drawing phasor diagram. Okay, how have they drawn? Though we can draw anyways. This is my V naught, which they are writing as Vm. V naught or E naught. Okay, same way we have drawn for resistance. This is omega t. and current is 90 degree behind it. This is current. In case of AC circuit containing L. Now in graphical presentation, it is important. See, voltage is sine function. So there is no problem. We can draw a sine wave for voltage. This is for voltage. Okay, this is for this. Now, for current is lagging by 90 degree. Either you can draw by that, or if you remember, current is like minus I naught cos omega t. Minus cos only we adjusted, if you remember. Otherwise, it's okay. It is lagging by, make it positive, sine omega t minus 90. You know, either you do by this or you do by this. I will do by this minus cos. So what is minus cos? Cos 0 1. Cos 0 is 1, and here it is minus. So graph will start from here, and you already know it. The voltage peak value is little higher than that of current, so current curve will be smaller. So you can see even cos 0 1 and minus is a minus 1. Then I know it will go alternatively. The next value is 0, the next is positive 1, the next value is 0, the next is negative 1. So this is currents. So I can write here current's equation is, sorry, I have written E. I is equal to minus I naught cos omega t. So this is your I naught minus I naught. This is your positive I naught. This is your negative E naught. So you have to label it. Now this is 0 degree. This is 90. Then add 90. Then add 90. Then add 90. You can see here also. See, voltage is longer. This is V naught. Current is shorter. It is starting with minus 1. Cos 0 is 1, and then minus sign was there. So it is starting from here. Then minus I naught, then 0, then positive I naught. This is positive I naught, then 0. So it will go like this. So graph has to be drawn with utmost care. So coming to the next. If you remember, in this expression, current came as minus E naught by omega L cos omega t. Current came as like this. So let us see this expression. Where did we found this? So yes, here it is. You can see we got current as this. Then we wrote it as I naught. So okay, I am picking that up again. So I pick that up again. Now what we assigned it as? We assigned it as I naught. Fine. This is voltage and this is, so this is voltage. Current is voltage upon opposition. Right. That means omega L is opposition. This is current only, because current will be equal to current only. Trigonometry has got no dimensions. Now this is voltage. What is this? This is opposition. So it means we have got a term omega L, which we will give the symbol as XL. X for opposition, L for inductor. So this is a symbol for inductor's opposition. This is inductor's opposition. So the opposition offered by inductor to AC, to flow of AC through it, is called, it has got a name, is called dash, and symbol is XL. Formula is omega L. What is the name? Like resistor's opposition is resistance, inductor's opposition is inductive reactance. So this is a new important word for you, inductive reactance, and formula is omega L. So everyone knows how to open omega. Omega is open as 2 pi nu. So inductive reactance, that is opposition offered by inductor against frequency, you know it will be straight line because they are directly proportional. Okay, for direct current, for DC, frequency 0, DC is unidirectional, it doesn't change your direction. AC is like this. Okay, so DC is frequency 0, so there is no opposition offered by the inductor. Frequency 0, XL 0. So inductor offers no opposition to, this is an important conceptual, inductors offers no opposition to direct current. So inductor behaves as conductor for direct current. Inductor behaves as conductor to direct current. It's important. Now getting to next. So now we have AC circuit containing capacitor only. So first we will draw the circuit. So this is your source of AC source, and this circuit is containing capacitor only. So you know already that how much the general expression for alternating EMF is this, and if we wish we can write it by the symbol V also. Okay, anyways, one equation you will write. Now we all know Q is equal to CV, as we know the relationship between charge, capacitor and voltage. So you can write, as we know this relationship, so Q is equal to C E. If you have given the notation E, so you can write it as C E naught sine omega t. So now we know the relation I is equal to dq by dt. So let us substitute I is equal to d by dt to C E naught sine omega t. Let us take C and E naught being constant coming out. So d by dt of sine omega t. So I is equal to C E naught, sine's differentiation will be cos omega t, and omega will come out. What is with t will come out. So this omega is coming out here. So we got this. Now this we will put it as I not peak current, maximum current. So current's relation is this. Okay? And what was voltage? Voltage was E naught sine omega t. So I've got both, but then they should be converted into sine. This should be converted into sine. So how to convert? We can again, I will write those things, that sine 90 plus theta is cos theta, and sine 90 minus theta. Now you have to select a formula in which omega t should not be negative. So if I'll write here this formula, this is negative, so I cannot write it, so I'll be writing this. So my current would be, I naught sine this one. Okay, I just want to write omega t first. So my relation is ready. So from 1 and 3, what do you see? That this time current is ahead of voltage by 90. So write this thing: in an AC circuit, containing capacitor only, you can see from the equation current is leading. Current leads voltage by a phase difference of 90 degree or pi by 2 radian. You can write in terms of time also. It means the current will achieve zero, positive value, then zero, then negative value before voltage by a time difference of t by 4, right? Because 360 is for full time, so it is 1 by 4th. Now we have to come to the graphical presentation. So you can draw. So you can see if this is your current arrow will be small first of all. Then voltage is lagging behind by 90. This is your voltage. So this is phasor diagram, right? This is phasor diagram. And coming to the graphical presentation. So for that you pick up the relationship once again. My voltage is this. So there is no problem in drawing this. I will draw a sine curve. My current is 90 degree ahead of this. So positive 90 so this was converted into positive cos only. So I naught and this is positive cos. So cos 0 is 0. Sorry, cos 0 is 1. So positive 1. Current will start with positive 1. So okay, let us draw the graph now. Graphical presentation. For voltage, we don't even need to think. It's a sine curve. See, mine is drawn little wrong. You don't draw it flat anywhere. It shouldn't be flat. Avoid drawing flat. Huh? And now coming to this current is positive cos 0 1. So positive 1 से start होगा. Then it is alternate. 0, then negative 1, then 0, then positive 1. So this is your currents graph. So you can write that this one is your E is equal to E naught sine omega t. And this is your I is equal to I naught sine omega t. But then be very careful about the labeling. So many things are left in the graph to be labeled. This is your I naught. This is your E naught. Then minus I naught, minus E naught, then 0, and this is pi by 2 angle, then pi. So these all things to be kept in mind. Okay, coming to this thing once again. What was I naught if you remember? I naught was omega c E naught. And how have I written this? Go back, you will see. You can see this thing. This thing I wrote as I naught. So yeah, we saw that this was converted into I naught. So we'll pick this up. This thing is I naught. So I naught is omega c E naught. So this can be written as E naught by 1 by omega c, because omega c will then go up. So we can write it like this. So this is current, this is voltage, and this is opposition. So 1 by omega c is opposition offered by the capacitor Xc. So the opposition offered by capacitor to flow of alternating current is Xc, and its name is capacitive reactance. Capacitive reactance. So this is capacitive reactance. Capacitive reactance. We'll always remember this. Now this can be opened as 2 pi nu. This is C. So you can draw the variation against frequency. It's inversely proportional, so it is hyperbolic. So in this we have seen that in an AC circuit containing resistor only, they both are in same phase, current and voltage are in same phase. Okay? In an AC circuit containing inductor only, voltage leads the current by 90 degree, or you can say current lags. Current is here, voltage is leading. This is voltage across resistor. It is in same phase. And in an AC circuit containing capacitor only, voltage lags. So voltage across capacitor lags. Okay? Voltage lags. So how would you show? That current is here and voltage is lagging by 90 degree. This is current and this is voltage. Okay, one more thing we have learned, that the opposition of inductor is inductive reactance. Formalize this. And opposition of capacitor is capacitive reactance. Formalize this. Sorry, it's omega c. 1 by omega c. So prepare this properly. Thank you.